Welcome back to digital class, and now we are looking back again on about heat. So we have actually learned about heat in the previous video, and now we are focusing more on the effect of heat. So now again, the properties of heat, we also learned that heat is always actually transferred from a hotter region or a higher temperature region to a lower temperature region or a cooler region. Okay, so we can use the word hotter region also to a cooler region. Okay, and it will actually, until both stage or both regions reach the same temperature, then it will just maintain there. Okay, so an object's temperature changes when it gains heat or lose heat. Now what happens is when it gains heat, the temperature will rises. I mean, it's kind of normal. When it lose heat, the temperature will drops. It's a very normal thing. But what is special here is, again, this is very important. When an object gains heat, the temperature rises, it actually also expand and occupy more spaces. Okay, it gain heats, expand, occupy more spaces. So some of the examples here is metal railway tracks. So what happens is in summertime, it will be very hot, right? That's why the track also will expand. If it builds like this, it expand, it actually it breaks the whole thing. So what happens is you see there is a gap in between here, between the railway track. Why? Because it will expand due to heat and it will bend, okay? And it will break. So gaps is actually built here in between to allow for this expansion so that it will prevent any damage that might happen. Okay. Next, heat can expand and occupy more space. For example, this ping pong ball, as you can see, is a dented ping pong ball. What happens is we can try to put this ping pong ball in the hot water, and the hot water actually, the air in the ping pong ball actually gains heat, and it will expand and it will push up the dent in the ping pong ball, which is something that is very, very useful, right? Okay. And that's basically gaining heat. And again, as we know, when the heat is lost, when we loses heat, this in the opposite way, it will not expand, it will contract, and it will occupy lesser spaces. Okay. Now, and because of these features, it's very important that the electric cables is installed loosely on the post. So for example, I believe that you see some electric cable, right? Something like this. Okay. Then you see that all these wires like loosely. Why don't they just make it like tight? Example like this. Why? Because when it's in the lower temperature time, example like a very cold temperature, this will contract. When it contracts, if you like do it like this, like so tight, it contracts, it breaks. Okay, that's why it's very important that it actually loosen it, allows in contraction and expansion also that happens here. Okay, the same thing go for bridges. So sometimes the bridge you can see something like this, right? Okay, and you have a bridge. So again, all these things are installed in these ways because of heats, the effect of heat that might happens here. Okay, so important here. So let's move on and talk about heat conductor. So as you can see that we have heat conductor, means that materials that allow the heat to transfer very goodly. But of course, there's two different conductor. There's a good conductor of heat. There's a poor conductor of heat. So in simple, good conductor of heat means that you allow the heat, the material that allow the heat to flow through very quickly and very easily. And poor conductor basically means materials that allow heat to flow very slowly and less easily, means that it's kind of hard to flow. Okay, so for example, good conductor of heat, we have frying pan, we have kettles, and poor conductor of heat, we have the holder of the cooking utensil or double glaze cup. So for example, I have a frying pan here, and this part, as you can see, I need to use this part to go and fry something, right? Example, I want to fry an egg. Okay, fry an egg. And because I need to fry an egg, means that I need this part to be hot. Means that I must gain heat here. Okay? So I must put the good conductor of heat to allow heat transfer very fast. Example, if I put on fire, example, okay, I need the heat to go through very fast. Or else I'll just wait there for so long for the egg to be fried. However, on the other hand, I need to hold here, right? But if here is also good conductor of heat, wow, that'd be so hot, right? Then I cannot cook properly. So what happened is, on the other hand here, I need to put something that's poor conductor to prevent heat transfer when I handle the object. Okay, so how can I do that? I will put something that is poor conductor. For example, I have what? I have like maybe rubber, maybe I have wood. Sometimes I can put plastic. It depends on what I'm able to use here. Okay, again, so frying pan here need to be good conductor of heat, and here needs to be poor conductor of heat. Now, and I have this cup. This cup is kind of special because usually we have this normal cup, right? But this cup have this air trap here. Can you see? So this air actually trap here helps to keep the drink to be warm for a longer period of time. How? Because air is a poor conductor of heat. Now, let me write here again. Air is a poor conductor of heat. Now, this concept is just extremely important, so I need you to remember this. When air is a poor conductor of heat, it trapped in this space. So, because it's poor conductor of heat, so heat cannot go out that easily. That's why it slows down the heat loss, and that's the reason that the drink's able to be warm for a longer period of time. Okay, so heat, good conductor of heat and poor conductor of heat is something that's very important to understand here. Okay, so I believe that you have learned something here, and thank you. See you. Bye bye.